All right, let's just start. So take a look, try number one.
The answer is C.
Very good. How did you do that?
So I looked at the equation and I saw the common terms. So I saw five for the first term, so I was just trying to hit the other term to also get five so I can eliminate both of them.
Yeah, exactly. Yeah, so you want basically this side to just cancel out. So we kind of just like want 5 minus 40k to equal 0. And then if you solve that, you get 1/8.
Yeah.
Good. Nice. All right, how about number two?
A.
Nice. Yep. Whoops. Yeah, so all right, hold on. I have another person joining. Yeah, so I'll just go over this one too. So you could do if you just like simplify it a bit. And then what we need is the x's to be infinite. We need the x's to be the same on both sides. So basically, a plus 9 is 5. So a is -4. And we also need the constants to be the same. So b is -6. And then when we add them together, you get -10. Okay, let's try number three. So most of tonight's the theme is going to be kind of like solutions to kind of different things. So try three. Okay, so what I did for this one was I just simplified the right side as much as possible. So just a little bit of distribution. So the -3 plus 9x. And then I can combine that to 12x plus 9. And then I just kind of match it up here. So if you do, I mean, you could use Desmos for this as well, but if you're doing it this way, what we want is to have no solution. You want the coefficient of x or the x numbers to be the same, which is like the slope being the same. And then you want the constant to be different, which is like the y-intercept to be different. But that automatically happens. So really, we just need the 1/3 a to equal the 12. If you multiply by 3, a just has to be 36. Another option is to just throw it in the Desmos, put this in the first one and this in the second, and then just kind of make a slider and you just make it all these values, and you'll see that when it's 36, you get a pair of parallel lines. All right, now we jump to systems. So try four.
There a typo on the answer choices?
I don't believe so because I did it and got one of the answers. Yeah, so let's take a look. I'll show you how I did it, and then we'll see if I made a mistake or not. So if I want infinite solutions for a system, I want to make them look exactly the same. So I multiplied the top equation by 3 and the bottom equation by 2. And when I multiply the top equation by 3, I got 12x minus 3ay equals 60. And when I multiply the bottom equation by 2, I get -2bx plus 6y equals 60. So that's what I wanted. I wanted these both to be 60. And then I'm just going to choose values of a and b that are going to make everything else the same. So if I start with a, I'm going to make a -2 because -2 times -3 gives me the +6 that I have down here. And then I'm going to choose b to be -6 because -6 times -2 is this +12. And then when I add them together, I get -8, which is A.
Oh, I think I did the opposite of what you did. So like I plugged in values first and then try to make it equal 60. But yeah, this makes sense.
Okay, good. Yeah, so generally what I try to do when it's in standard form is if it's infinite solutions, I just want to make everything exactly the same. No solutions, you want the X's and Y's to be the same, but over here actually needs to be different. But they'll just work out that way by whoever made the problem. So like I can't focus on the X's because I don't know B, and I can't focus on the Y's because I don't know A. So I just focus on that over there. Um, and I don't use Desmos for this because I don't want to use two sliders without any information on either slider. I think that's kind of too hard to mess with. So I just think this way is easiest. All right. So let's keep it going. Okay, so now we have an open-ended one, similar type of problem. Okay, so there are multiple ways to do this. But since if it was since it was infinitely many, I kind of always take the same approach. I just want to make them look exactly the same. So I focused on the constants over here. So since they have to be exactly the same, I just doubled this equation. So I end up with 2cy is 2bx plus 12. Now, if I wanted to, I could find C. The problem doesn't ask for it, right? But if you just look at like conceptually how we look at these, this and this have to be the same. So I know C is 2, but I don't need that. But what I also need is the coefficient of X to be exactly the same. So I need A to equal 2B, which is interesting because I can't actually solve that equation. But this is why they asked me what A over B was. So if I just divide by B, then A over B has to be 2. So the answer to the problem is 2. A and B actually don't need to be very specific values, but whenever we divide them, we will always get 2. So it's a bit of a harder problem, but the final answer is 2.
Wait, can we say the answer out loud like once we're done?
I guess just wait so we don't know. Because I always go over the problem anyway, because I record these and like put them on YouTube and all for other
Okay,
people to watch. So yeah, I guess just if you want to do what you did, just send me the answer in the chat and I can tell you if it's right or not.
okay.
Yeah, thanks. Okay, let's try that one. Okay. So I'm gonna take a different approach here. Um, Given it's no solution, and I'm going to show the way if we get them in slope intercept form instead of keeping them in standard form, because these are kind of in between. So this first one, if I add the 6y over, I get 15y equals 12x plus 14. And then I divide everything by 15. I'm just gonna leave it like that for now. And then this one, if I divide everything by 4, I get negative k over 4x plus 2 over 4. So again, I don't really care about that. So what I know is that when there's no solution, the slopes have to be equal to each other. So this is really 4 over 5 has to equal the slope over here, which is negative k over 4. And then I'm simply just going to cross multiply. So I get 16 is negative 5k. So in the end, I get negative 16 fifths is the value of k. So either if they're in standard form, the x's and y's have to be the same and the constants different. Or if you get them in slope intercept form, the slopes have to equal each other and the y-intercepts are different. But again, I didn't really care about these. They just kind of have to work out that they're different. Okay. All right. So this one I chose to do the standard form way, just because I thought I could get them both easily in standard form, whereas the last problem I just felt it was easier to get it in slope intercept form. And I could do that by just adding the ky over. So I just get negative 5x plus ky equals 8. And then this one, I just add the 10x over, and I'm going to put that first. So 15x plus 18y equals 21. So I just do that first. So basically, the way I look at these is since it's open-ended, I don't love using Desmos because I don't like using a slider without having options. You can find it. This one you probably be able to, but like the last one, the way the answer was would have been much more difficult. So then I just say, is it easier to get everything in standard form or slope intercept form? So this one I felt was standard. So when it's in standard form, what I want is I'm going to focus on the x's. I want them to be the same. I want the constants to be different, but I don't want to focus there because there's an infinite number of ways to make them different. But I want to focus on what I want to make the same. So here's the x's. So I'm going to multiply by -3. So my new first equation is 15x minus 3ky equals -24. So again, the constants are just going to work out to be different. If by multiplying by -3, these ended up being the same, then whoever made the problem just like didn't make a good problem. So don't really worry about that. I need the x's and the y's to be the same. So I make the x's be the same. And now I can see that k, be careful here, must equal -6 because -6 times -3 would give me the positive 18 that's up here. All right. Then now we start looking at quadratics and solutions to those. All right. So try number 8. Okay. So for this one, I'm going to do this two ways. The first way is by using what's called the discriminant. So we kind of looked at linear equations and then systems. Now we're talking about, whoops, now we're talking about quadratic equations. So the thing that's going to help us determine the solutions, again, if we do it by hand, which is how I'm going to do it the first way, is we use the discriminant, which is b squared minus 4ac. And what there are three things to know. I'll just go over all of them right now. Is we if that is greater than 0, then there are two real solutions. And that is because the b squared minus 4ac is the part that's under the radical in the quadratic formula. So if you have a positive, you'll be able to square root it and you'll get the plus or minus solutions. Now, the one that pertains to this problem is if it equals 0, you're going to get one real solution because you'll take the square root of 0, which is 0, and plus or minus 0 gives you the same answer repeated. And then finally, b squared minus 4ac could be negative. Can't square root a negative, so you get 0 real solutions. And we don't have to worry about imaginary stuff on the SAT, so we would just get no solutions. So a way to do this problem is to just pick this one because we want one solution. B squared is 30 squared, which is 900, minus 4 times A, which is -9, times C, which is C. And if that equals 0, then I just get 900 plus 36C equals 0. And then 900 is -36C. Divide by -36. And 900 divided by -36 is -25.
One question.
Yeah.
So I see we got -9 x squared and then plus 30x. So couldn't you just like take the common factor out?
Take common factor out of 9 and 30.
Yeah.
You could, but then what do you do after that?
Oh yeah, that's true.
Because like if you divide it out, then you'd have to divide C by that number as well.
Yeah.
So like you could do that, but did that lead to the answer?
Yeah, I did that. I just want to know like which one's like the longer way to do it though, or
Yeah, I
like
mean
the shorter way.
yeah, if that worked for you, I mean, I guess just compare it to what I did. I mean, to me, the discriminant is, did you end up using the discriminant?
Yeah.
Okay. Well, then I would probably just use the discriminant so that you don't have to like, if you're going to use the discriminant anyway, I don't know if simplifying like helps that much.
Yeah. Got it. Thank you.
Yep. Now, I like to go over because like right now I just like to go over all of the concepts. If this were open-ended, then certainly I would use the discriminant. But the fact that it is multiple choice, I am going to just go over the Desmos way. Um, so let me just go to Desmos. And what you can do is just type it in kind of as is. So negative 9x squared. Whoops, it's not showing up. There we go. So negative 9x squared. And then it was plus 30x plus 30x plus c. And then just add the slider. And then basically all we're doing is just putting in all the answers. So like when you try 3, you can see that it crosses the x-axis twice. When you try 0, it crosses it twice. Then when you try negative 25, it crosses once. And just to be safe, if you try the fourth answer, negative 53, it doesn't cross at all. So this might actually be the fastest way, because then you don't have to do anything. So it's like I like Desmos when it's a slider or a constant problem, and there's only one of them, and it's multiple choice. Then you can just like run through the answers. And so in this case, we're looking for one x-intercept because it's telling you one solution. Okay. Any questions on that way of doing it? Okay. So let's jump back here. But even if you're going to do it the Desmos way, you still need to understand the discriminant, I think, because there are problems where Desmos would be very difficult to do. And here's kind of an example of that. So try number 9. Okay, so if we were to use Desmos, we would throw this in, but we'd have to kind of mess with it to find B that would like the largest value of B such that there would just be no x-intercept. So rather than just like messing with that, I'd rather just jump right to the discriminant. So based off what we talked about before, B squared minus 4AC has to be less than 0 in order for there to be no real solution. So B is B, so I still have B squared. Then I have minus 4. I'll write this out. And then A is negative 1, and my C is negative 676. So if I multiply this together, I got negative 2,704. So therefore, B squared has to be less than 2,704. We know it's positive, so I'm like allowed to do this, and then I can just square root both sides. So for the positive part of it, B has to be less than 52. Be very careful when you're like doing the discriminant. Sometimes students like don't write the inequality and then they think the answer is 52. But B has to be less than 52. So the greatest value that B can be if it's an integer is 51. So the actual answer to the SAT problem is 51, not 52. So I've seen a lot where students do the discriminant and then they just get 52 as the answer because in their work, they kind of lose the inequality, but it is at less than throughout the whole thing. So the only answer to the question is 51. Okay. And again, I don't love Desmos. You have to mess with the slider, the normal values to get it to be more than go past 10. So rather than deal with all that, I'd rather this to me is a much more straightforward. Okay. So let's try number 10. Okay. So for this one's a little bit tricky, especially the way that the last one was worded. This one's slightly different. I mean, two real solutions makes it a little different, but this part, whoops, keep forgetting the marker. But this part makes it a little bit different. So here's how I did it. So if it has two real solutions, then the discriminant b squared minus 4ac has to be greater than 0. So B here is -8, and -8 squared is 64. Then I have -4. A is 1, and C is K. So I have 64 minus 4K is greater than 0. What I did was I just added 4K to the other side, so I get 64 is greater than 4K. Divide by 4, and I get 16 is greater than K. But I'm going to write that backwards because I want it to match this. So I'm going to write the K first. So K is less than 16. Now, it didn't ask like the last problem. It didn't ask for like the largest possible integer because then the answer would have been 15. It asked for what's the least possible value of m. Well, if you just look, m m can be 16. If n is anything bigger than 16, then this statement wouldn't be completely true. So the smallest that m can be is this. So you just simply look at it as I match these up and the m is being replaced by 16. So the answer to the actual problem in this case is 16. So it's just they asked the question a little differently than the problem before, which is why we end up interpreting our inequality a little bit differently. All right, let's try number 10. Okay, this one also I'm going to do two different ways. And this one I'm going to do the Desmos way first because I think that's probably the fastest, but I just want to kind of go over both. So the Desmos way that I would do it is first graph the one that's given. So -x squared plus kx minus 10. Add the slider. And then I'm going to graph y equals 15. I'm going to zoom this out so I can see 15. So like there, that looks good. Okay. So then I'm simply going to just check the answers. So the first answer is k is -10. And what I want is it says it wants there to be one intersection or one solution, and this actually is the answer. You can see the parabola hits this line once. And if you want to double check, when you throw in the other answers, -8, it doesn't intersect at all. +8, it doesn't intersect at all. And 12, it intersects twice. So -10 is the answer. So to me, that's a really easy one to just use Desmos. Again, because it's multiple choice, we can just throw in the values very, very quickly and just see what we're looking for. Okay, so first, any questions on doing it that way? Okay, so then I am going to show you the other way. And again, all they would have to do is make this problem open-ended, and then it would be a little bit harder. Open-ended would be tough because there's actually ends up being two answers, but I'll show you that. But again, it's good to just know that you have an alternative way in case Desmos is not working out for you. So to do it that way, you would simply just replace the y with 15. So you get 15 equals -x squared plus kx minus 10. Quadratics, we always want it to equal 0. And then if we want this equation now to have one solution, then I'm just doing the discriminant. So I want b squared minus 4ac to equal 0. That gives you one solution. So I get k squared minus 4, a is -1, and c is -25. Whoops. So this is k squared minus 100. Whoops, that should equal 0. So k squared minus 100 equals 0. So k squared is 100, which means k is either plus or minus 10. So this is why if it were open-ended, there'd have to be two answers, which is fine. There's some questions like that. Or they'll tell you like k is positive or k is negative to kind of force there to be one answer. But clearly here with multiple choice, we know it's A because that's either 10 or -10. So this is the discriminant way. I think this is longer than Desmos, but again, it's important to know those concepts just in case you have a problem that's similar but not open or not multiple choice. All right, then let's take a look at this one. Okay, so I guess I am going to do this one both ways. So the first way, kind of by hand, is if the solutions to the equation are integers, then that just means that it must factor. So for instance, if x squared plus, if let's say p were 9, if you can factor quickly, then you could just do it this way. We should know that this will now factor to x plus 6, x plus 3. So therefore, since it factors nicely, our answers will be -6, -3, which are integers. So 9 would work. If you try x squared plus 17x plus 18, that is not going to work because the only way you're going to get 17 is with 18 and -1, but then that wouldn't give you positive 18. So this doesn't factor. Doesn't mean that it doesn't have solutions. It just means there's no way those solutions are integers. So that does not work. And then for 19, if you have x squared plus 19x plus 18, that factors to x plus 18, x plus 1, which means your solutions would be -18, -1, which again are integers. So it's going to be 1 and 3. So first, questions on that. So it might just be faster to use Desmos. So if you use Desmos, the way you would do it is you could just put in the x squared plus px plus 18, add the slider, and now just make p each value. So you make p 9, and then you just look at the intercepts, and the intercepts are -3 and -6, which are integers. So we know that works. And then when you change p to 17, you can just look, this first intercept is not an integer, it's a decimal. So again, we end up with two intercepts, but they're not integers, which is why it didn't factor. And then if you make it 19, you get -1 and -18, which again are integers. Right. So this probably is faster. You just run through all three options and you see, you just got to know what you're looking for. And we see that for 9 and 19, we get x intercepts that are integers. Okay. Um, go back here. All right. So that was, yeah. So the answer was C. Okay. That's all I have. I just usually pick 12 problems. If anybody, we still have some time. If anybody has any problems they wanted to send me, I could do them. Um, or we can stop a little early. It's really, I'm fine either way.
I don't have any.
Okay.
Yeah, I don't have anything either.
Okay. Sounds good. Cool. All right. Well, thanks for coming. I'll send out the email again. If you ever do have any problems, you can just email them to me. And I can make sure I make those part of it. But if you don't have problems, then I'll always have problems that I'll have coming into the session.
Perfect.
Okay.
Thank you.
All right. See you later.
Yep, see you next week.